Okay, in this section we're going to learn the decomposition of some function n of x over d of x into partial fractions. And basically what we're going to be doing is something like this. Trying to find, when we have a fractional expression, trying to find the two partial fractions that were added together to get this for an answer. So how do you find those two fractions if all you have is the answer? So I'm going to show you how to do that. Let's leave this here so we can sort of have it to glance at if necessary. There we go. All right, now, so here's what we're starting with. We're starting with this fraction, and we want to figure out what were the two fractions that it came from. So the first thing you want to do is factor. So let's keep the top the same and factor the bottom. Now, I hope you realize that this factors into two binomials, factors of minus 6, minus 1 and 6, 1 and minus 6, minus 2 and 3, 2 and minus 3. I think I want the plus 2 and the minus 3. I need middle of negative 1. If I double check, I've got that. So now I know what the bottom of the fraction has to be. So I take and I separate it out and write it as two separate fractions. So x plus 2 over x minus 3. And now what I have to do is try and figure out what goes on top of those fractions. So at this point, I don't know what goes there, so I put an A here and a B here. And now we're going to be able to figure that out. If I were to add these two fractions together, I'd need common denominators. You agree with that, right? Which means this fraction needs on the top and the bottom x minus 3. What does this one need on the top and the bottom? X plus 2. Now, if we want to solve this, we can basically set the thing equal to 0 and solve the parts separately. So, let's just take the top. So we have x plus 7 has to equal a times x minus 3 plus b times x plus 2. And we work from there. So now we're going to try to solve to find the a and the b of this expression. All right, so let's see what happens. So I take x plus 7 equals a times x minus 3 plus b times x plus 2. And now I try to solve that by choosing either negative 2 or 3. Let's do negative 2 first. So I'm going to do let x equal negative 2 and see what happens in this whole expression. Negative 2 plus 7 equals a times negative 2 minus 3 plus b times negative 2 plus 2. Hopefully you see that becomes a 0. So I get 5 equals negative 5a plus 0. I get a equals negative 1. There's one of my fraction tops. All right? And that is the top for this one because I let x equal the negative 2. Now I'm going to do the same thing again with the other fraction. So watch this. This time I'm going to do, again, I have x plus 7 equals a times x minus 3 plus b times x plus 2. This time I'm going to let x equal, remember, 3, right? These are the two values I'm looking for. All right, so when x is 3, I get 3 plus 7 equals a times 3 minus 3 plus b times 3 plus 2. That becomes a 0, so I get 10 equals 5b. Solve for b. I get b equals 2. So there's the other top of the fraction. So I got a equals -1 and b equals 2. So there is my fractional decomposition. B equals 2, a equals -1. The 2, when I let the 3 equals 0, I got 2, so that goes here. When I let the 2 equals 0, when I let x equals -2, and this one to get 0 on the bottom, I got -1. So there you go for your postural fraction decomposition. You can try this now. Good luck.